really stinky for those that aren't here right now. But I'm going to start recording from this point. No idea how that happened. Gotta love internet and technology. Okay, so can you tell me, let's see, if you're looking at the graph here, I just want to try to figure out when I got cut off. So did you hear me do this problem here? I think this is problem number 5. This is probably the 5th graph with an amplitude of 2 and a period of 4. All right, did I get through at least that much? So let me go back to my chat here. You saw me draw the red line, and that's it. Okay, good. All right, so let's review only. I don't know what that means. Could you clarify that? Review only? Okay, so let me redo this problem because somebody said they only saw me draw the red line. All right, I'm assuming you mean the red line down here at period. So let me clear this and we'll start this problem again. Okay. So again, this is the negative cosine function. Because again, you want to look at the origin to look for the starting point. And in this case, the starting point is below the origin. So if you take a look at your little graphic here, that's this 4th one here at the bottom right. Right? Cosine is the only one that starts below the origin and then kind of goes up a big hill and down a big hill. And then it repeats itself, right? Up and down and up and down and so on. Okay? So that one there is the negative cosine function. So save that for later. Now, what's the length of that? So from the first point to the last point of the negative cosine shape, that's going to give us the period, which is the length of that. And notice it starts at x equals 0 and goes to x equals 4. So therefore, the period is 4 minus 0 is a length of 4 or a period of 4. And then if we use the height, let's use the maximum point. All right, so the height from the midline, so the midline here looks like the x-axis again. So the height from there to the maximum gives us the amplitude, or amp. So it looks like we're going up as high as 2. If we use a minimum, we go as low as -2. So the amplitude is simply 2. So 2 is the amplitude and period is 4. All right, and finally, number 6 here. All right, so number 6. Now, take a look at this. This one is a little different. Where is the midline? This one is different from the other 5 because now I've shifted the midline up. So hopefully, you know, you can kind of see, like, I could probably divide this thing through 1. All right, so that would be at y equals 1. Okay. Now just think of the midline as your new x-axis. Okay, your x-axis has been shifted up 1. So now what function are we looking at here? All right, so this midline is now my new x-axis. All right, so you want to think of it like that. All right, so now the function itself, so since this starts below the new x-axis, it has that particular shape. All right, it's starting below the new x-axis. Don't look at the solid x-axis, look at the dotted one. This is our new x-axis or midline. So it's shifted up. So that means we're starting below the midline. So this is a graph of a negative cosine function. Okay? And again, that's because if you take a look at the bottom right figure, it has that same exact shape. All right? So remember that your horizontal axis, you might want to add that here, the horizontal axis in these graphics is the midline. So you have to look for the midline to really figure out the shape. So the horizontal axis is the midline. Okay. So now let's figure out the amplitude and the period of this graph. So what's the horizontal length? Right? So that would be our period. So it goes from where? 0 to 3/2. So we do 3/2 minus 0 is 3/2. And then we want the amplitude. So let's find a maximum point like up here. So remember, it's the distance from the maximum to the midline, not the x-axis, the midline. So that's only from here to here. All right? So that's just between 1 and 2. So therefore, the distance is 1. All right? So the amplitude is really 2 minus 1 is 1. You didn't have to worry about that when the midline was the x-axis. You didn't have to subtract because you were just subtracting 0. All right? So technically, a better definition of amplitude is it's the difference of the maximum value and the midline. The maximum value and the midline. Or the midline and the minimum value. Same thing. All right? So in this case, the midline is 1, the minimum is 0, so 1 minus 0 would also give you 1. Okay. All right, so we're going to come back to these after our next group work, and we're going to write out the equations of these. So I'm going to save all that information for later. All right, but before our next group work, we're going to do one more thing here. So now that we know how to find amplitude and period, what if we do it the other way, where instead of me giving you the graph and you tell me what the amplitude and period are, let's do it the other way around. What if we know the amplitude and period? Can you sketch the graph? All right, can you sketch the graph? So sketch one full period of a sine or cosine function. So let's write out some rules here on how to do that. So you're going to need, you need to transform the 5 key points. Okay, and here's how you do that. So step number 1, to get the x values. All right, so for example now, for sine, all right, the key x values are, remember they were what? 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now you're going to have to transform those to different values if the period isn't 2 pi. So those are the key x values when the period is 2 pi. What if the period is something else? What will those 5 numbers be? Okay, so here's what you have to do. All right, so number 1, find the period, right, which is 2 pi divided by b. And then the 5 key x values will be 0. 0 is nice because that never really changes. That will stay 0. And then the next one will be 1/4 times the period, 1/2 times the period, 3/4 times the period, and then 1 times the period, which is the period. Okay? Oh, this is also for cosine as well. Cosine of x and sine of x. Okay? All right, so why are we multiplying them by quarters and halves? Okay, well, take a look at, if I can find it, right up here. So when you take a look at the sine and cosine graph that we drew here, notice how you have 1, 2, 3, 4 numbers on the x-axis after 0, and they're evenly spaced. So you are dividing up the graph there into quarters, but they don't go up exactly by 1/4. All right, they go up by a certain angle measurement, but these are quarters of a circle. All right, so remember, pi over 2 is 90 degrees. That's 1/4 of a circle. Pi is 180 degrees. That's half of a circle, or half of 2 pi, half the period. 3 pi over 2 is 270 degrees. That's 3/4 of a circle. And 2 pi is the entire circle. All right, so those fractions there of 1/4 and 1/2 and 3/4 represent the fraction of the period or the fraction of the whole circle. Okay, and 2, to get the y values. Now, sine of x has key values, key y values of 0, 1, 0, -1, and 0. Those were from the table in the graph that we drew earlier. And for cosine of x, the key y values were 1, 0, -1, 0, and 1. And this is for when a equals 1. Right? Because the original functions had an amplitude of 1. So what about other amplitudes? What would those key y values be? So there's only one step here. You multiply your key y values by a. Not absolute value of a. Okay? Now let's do some examples. All right, so the first example. All right, number 1. So let's say we have f of theta equals 2 cosine of 4 theta. So the first thing you want to do is identify your a and b values. So a is 2 and b is 4. So what we need to do first, remember, we want to plot this function with one full period. So first we need the x values. Right? So what we do is we follow these steps right here. First you find the period, and then you multiply the period by these fractions. And then you have your x values. Okay? So the period is 2 pi over b. So 2 pi over 4 is pi over 2. So the period is pi over 2. So that's step 1. Step 2, all right, we'll get the x values next. So remember, it's 0, and then it's 1/4 times the period, 1/2 times the period, 3/4 times the period, and then the period itself. Now simplify that, simplify it. You get 0, that's pi over 8, that's 4 times 2. This is pi over 4. This is 3 pi over 8, and that's pi over 2. So notice, like, for example, 3 pi over 8, that's just found by multiplying 3 and pi and 4 and 2. So you multiply your numerators and your denominators, and you reduce where possible. So these are my key x values. Now for the key y values, remember, all I do is what? I take the cosine, so the key cosine value, so the key cosine y values get multiplied by a. All right, it's the cosine y values because look at the name of the equation, it's cosine, not sine. So the cosine y values are 1, 0, -1, 0, and 1. Multiply that by a, which is 2. And that gives us 2, 0, -2, 0, and 2. So you just multiply everything inside the braces by 2, and you have your y values. So therefore, my key points are 0, 2, pi over 8, 0. Oops, goofing up my parentheses here. Pi over 4, -2. 3 pi over 8, 0. And pi over 2, 2. So how did I put that together? I paired together the first number in each of the key values. So I paired together the first number in x and the first number in y. So that was 0 and 2. Then I paired together the second number in each set, pi over 8 and 0. Then the third number, pi over 4 and -2. Then the fourth number, 3 pi over 8 and 0. And the last number in each set, pi over 2 and 2. Now I'm going to plot these. So I know that my cosine goes up the 2 and down the -2. And on my theta axis, all right, we have just those key values, pi over 8, pi over 4, 3 pi over 8, pi over 2. Now we plot the points, 0, 2, pi over 8, 0, pi over 4, -2, 3 pi over 8, comma 0, and pi over 2, comma 2. There we go. All right. And make sure you label the axis. And the reason why I want you to label the axis is to prove to me that you were able to find the numbers that go on there. Because otherwise, take a look at the shape of the graph in red. That curve there, if we go back to the beginning, it looks just like this. It looks exactly like that. All right? So that means any cosine graph you could always draw just like this. But it's no good unless you actually find the values that it passes through. Because otherwise, they're all going to look exactly the same, but the numbers have to change. So you are required to show the numbers as well. Because otherwise, every cosine graph will look just like this. Let's do another example. These are a little messy because you have a little bit of work to do. So example number 2. Let's say we have f of x equals -3 sine of pi x. Okay, so identify the a and the b values. You need those first. So a here would be -3, and b is pi. All right, x is the variable, so it's not pi x, it's just pi for the b value. So the first thing we need to get are the key x values. So remember, there's 2 steps. You get the period, which is 2 pi over b. So it's 2 pi over pi is 2. This is going to be a nicer problem because pi drops out of the period. So when we find the x values, it's actually going to be a lot easier. All right. And then the next thing we do is remember that the x values will be found now by taking 0 and then 1/4 times the period, 1/2 times the period, 3/4 times the period, and the period itself. And that will equal, by reducing, we get 0, 1/2, 1, 3/2, 2. So now the period there goes from 0 to 2, all right? And look how evenly spaced the numbers are. They're spaced in halves. So that makes a little more sense there. The key y values, remember this is sine, so we want the sine y values, right, times a. So here the sine y values are 0, 1, 0, -1, and 0 times -2. Oh, not -2, -3, my bad. The a value is -3. So now by distributing that, 0 times -3 is 0, 1 times -3 is -3, 0, 3, 0. So finally, my key points that I will now plot are 0 and 0, 1/2 and -3, 1 and 0, 3/2 and 3, and then 2 and 0. So now remember what you do there, you just pair together your x and y values from these two steps. Pair them together, and you have your key points, which we now can plot. X and y. So remember, the a value is 3, which means we're going to have an amplitude of 3. So that means your curve will stretch up to 3 and down to -3. Label the x-axis with the key values of 1/2, 1, 3/2, 2. All right, now plot the points. 0, 0, 1/2 down to -3, 1, 0, 3/2 up to 3, and 2, 0. And that looks like a negative sine function, right? Because the problem was -3 times sine. So this is a negative sine equation, and when we plot it, we get a negative sine looking graph. Okay? All right, let's do one more, and then we're going to do our 30 minutes lab and break. So let's say we have y equals, let's see, I've done negative sine and I've done positive cosine. Let's do a positive sine. So let's say we have 5 times sine of pi over 3x. So we're going to do the same thing. We're going to find the key points and plot. So in order to do that, first you have to tell me what a and b are. You need those numbers. All right? So 5 and pi over 3 would be a and b. Remember, x is your variable. That's not a number, so you don't write that down. All right, first step, let's find our key x values. So remember, step 1 is to get the period, which is 2 pi over b. So here we get 2 pi over 3. Now you need to simplify that. You need to simplify it. So that would be 2 pi times the reciprocal 3 over pi is 6, because the pi's cancel out, and then it becomes 2 times 3. So you're multiplying by the reciprocal to get that. Now this is a great period because it's a whole number value of 6. This will be super easy to work with. So now we get our x values. So remember, you bring down 0. And now remember, we're going to multiply that period of 6 by fraction values that go up by quarters. So we're going to have 1/4 times 6, 1/2 times 6, 3/4 times 6, and 6 itself. So the last number there should always end with the period. Now I would simplify those. You better simplify. So we get 6/4 is 3/2. 1/2 of 6 is 3. And then we get 9/2, and then 6. So there's your key x values. The key y values. So remember the key y values. So remember, this is a sine function. So we need the sine y values multiplied by amplitude a. So that would be, the y values of sine are 0, 1, 0, -1, 0. multiplied by 5, right? A is 5. So that gives us values of 0, 5, 0, -5, 0. And now I have my y values. So my 5 key points then are just found by pairing those together. So the first one is 0, 0, 3 halves, comma 5, 3, comma 0, 9 halves, comma -5, and 6, comma 0. And now you plot them. So again, because the amplitude is 5, right, our y-axis needs to go up and down to 5 and -5. And then the x-axis, we'll use the key x values. They just get evenly spaced because, remember, they're evenly spaced by quarters, all right? So we get 0, 3 halves, 3, 9 halves, 6. And now plot those 5 points nicely. So 0, 0, 3 halves, comma 5, 3, 0, 9 halves, -5, and 6, 0. And then that looks like a positive sine function, right? Because the equation, what was the equation? It was positive 5 sine. So it's a positive sine function, but with an amplitude of 5, right? All right, so right there is where I'm going to pause now for our next group work, number 2, for 30 minutes. This way we can get a little break in there also. So you will do numbers 2, 3, and 4 from the lab. All right, you should be able to do that much. All right, so I'm going to unshare my screen. I'm going to pause the recording. Hey, everybody, welcome back. Let's now continue. So the first thing we want to do here, let's just make sure we're doing okay here with finding the key values for some of the problems in number 4. So I have up here on the screen for 4A how to find the key values. So in 4A, remember, first to get the x values, we need to find the period. So the period is found by taking the b value of 2 and dividing that into 2 pi. So you get 2 pi over 2 is a period of pi. So remember, now to get the key x values, all right, you start with 0, and it's always 0. And then you do 1/4 and 1/2 and 3/4 times by the period. So it's 1/4 times pi, 1/2 times pi, 3/4 times pi, and then finally 1 times the period, or just the period. So it's just pi for the last one. So therefore, 1/4 times pi is pi over 4, 1/2 of pi is pi over 2, 3/4 of pi is 3 pi over 4, and pi itself is pi. And now to get the key y values of cosine, all right, you take the key cosine y values, multiply them by a, right? A is 4 in that equation, and it gives you these y values. So these are the key x values, these are the key y values. So remember that the first thing you have to really show me on your lab are the pairs. Show me the pairs, the xy pairs. So that would be what? 0, 4, pi over 4, 0, pi over 2, -4, 3 pi over 4, 0, and pi 4. So this is the first thing you have to show me are the key points. And then you have to graph those. All right, and in b, the b value there was pi over 4. So therefore, the period should be 8, right? Because you have to do 2 pi divided by pi over 4. That will be equal to 8. And so remember, since the period is 8, then the first key x value is 0. Then it's a quarter times the period, a half times the period, 3/4 times the period, and 8 itself. So when you simplify those, you get really good numbers of 0, 2, 4, 6, and 8 for the key x values. And then the y values, this was a sine equation. So you take the sine y values, 0, 1, 0, -1, and 0, multiply that by your a value of -2. And then that gives you these y values here. And again, the first thing you really have to show me are the key xy values, which would be 0 and 0, 2, -2, 4, 0, 6, 2, and 8, 0. And then don't forget, make sure you plot and label it with those numbers for full credit. Okay, then let's keep going here, because now that we can at least identify amplitude and period and the key points of the function, let us now look at writing the equations. Writing sine and cosine equations. And that is given amplitude and period. All right, so first, these types of equations have a special name. Sine and cosine equations are sometimes called sinusoidal functions. That's a really strange word, sinusoidal. All right, but it kind of sounds like you're saying sine at the beginning, like sine and cosine, okay? Now, the word sine and cosine, notice there's a sine in cosine, okay? These are actually derived from the Latin word sinus. So notice you have sinusoidal. It's a very strange word, but it's a way to describe sine and cosine functions. And the Latin word for sinus is where we get sine and cosine from, but also this is where we get the word for our sinuses, like in our face and our nose and our cheeks, right? The sinuses that we have in our bodies. There's a little bit of a similar meaning between those things. Of course, you know, when you think of your sinuses in your face, you don't think of trigonometry. All right, but there is an interesting connection between those, and I won't get into that, but it's interesting that both the trig functions and our sinuses in our face are derived from the same Latin word. So for maybe a little an aside assignment on your own, if you're really interested in that connection, you could Google that. Okay, now, so since we're given amplitude and period, all right, we have to be able to find A and B from the amplitude and the period. So recall that the absolute value of A gives us the amplitude. Okay, so remember that we use a positive A if the graph is positive sine or positive cosine. And we use a negative A if the graph is other. So negative sine or negative cosine. And also remember that the period is 2 pi divided by b. So here we're trying to find A and B. So it would be helpful if we rewrote the equation to get B. It actually ends up being 2 pi divided by period. So you can actually interchange period and B, and then you can solve for B given the period. So you would just do 2 pi divided by the period, and that would give you the B value of the equation. So let me give you a minute there to catch up on the writing, and we'll do examples here and also on the plots of the week. All right, so example number 1, excuse me. Suppose that we know, so let's say we have a graph of a positive sine function. I'm just making that up to make it easy. And let's say it has amplitude of 8 and period of 12. All right, so the first thing we can say is this. Because it's positive sine and the amplitude is 8, that means the A value is positive 8, or 8, right? Just 8, regular 8. And then because the period is 12, to get the B value, we can just divide by period. So that would be 2 pi divided by 12 is pi divided by 6. And therefore, my equation is y equals, remember it's a times the sine of bx. So it would be y equals 8 times the sine of pi over 6x. Now, if you could use other variables. You could say f of x. You could say f of x equals the sine of pi over 6x. If you don't like x's and you want to say theta, you could say f of theta equals 8 sine of pi over 6 theta. Use any letters that you like. Just be consistent. All right? But what I have boxed off is a good enough answer as well. You can use other variables, other names, and the math gods will be happy. All right, so let's say we have another graph, which happens to be that of a negative cosine with amplitude of 1/2, and the period is 8 pi. So could you think to yourself real quick, what's the A value of this equation? Is it 1/2 or is it negative 1/2? Remember, you have to consider the type of graph that you have. It's a negative cosine function, so that means we need our A value to be negative 1/2. It has a very small amplitude. It only goes up to 1/2, so it's a very small graph. And now the period will help us get us the B value. So 2 pi over period is 2 pi over 8 pi. So that means the pi's cancel, and I get 2 over 8 is 1/4 for B. And remember, it's a cosine function, so make sure you write COS in your equation. So therefore, the equation is, let's use f of x equals, so remember it's a, it's a cosine function of bx. So it would be f of x equals negative a half of cosine times 1/4 of x. Some people will write that fraction a little differently in the parentheses. They might write it as x over 4 instead of 1/4 of x. Okay, but this is fine also. Just remember that when you have x over 4, it's really 1/4 times x. Okay, so if you can find that much information, you can easily write the equation, very easily. Okay, so now let's go back to the plots of the week. We had a couple of graphs where we wrote down amplitude and period. So let's get those equations for those plots in the plots of the week. Here they are. Okay, so this is back to page, I forget what page it is, but it's the one that says right at the top there, find the equation of each graph. Okay, so in number 1 there, we found that the amplitude was 2. We also remember that it's a positive sine function, and the period is 4, right? So then from the period, right, the b value is 2 pi divided by the period, which is pi over 2. And from this, the a value is positive 2. So I have my a and b, and therefore the equation would be y, or f of x, equals 2 times, and remember it was a sine function, so it's 2 times the sine of pi over 2x, or pi x over 2. All right, number 2, 3, 4. Okay, so now in number 2, the a value, all right, based on those two things, it's a positive sine function and the amplitude is 2. So the a value would be positive 2. And the period we said was 4 pi. So therefore, the b value is 2 pi divided by that 4 pi is a half, right? Because the pi's cancel out and you get 2 over 4 is a half. So therefore, my function or equation is y equals 2 times the sine of half of x. Very similar to the first problem, but just notice that here's an interesting thing. When you look at your x-axis to get the period, if you don't see pi in there, right, the period won't have pi. However, when you translate that back to b, you're going to have pi in the place of b. Here it's the opposite. If you look at your x-axis, you have pi's on the x-axis. So the period had a pi in it, but the b value does not. So isn't that interesting? All right, next, number 3 here. So note that we have a negative sine function, right, and an amplitude of 3. So therefore, what does that mean? A is negative 3. The period at the bottom there is pi. So remember, we can get the b value from the period. So it's 2 pi divided by period. So 2 pi over pi cancels the pi's out, and we get 2. So my a is negative 3. My b is 2. It was a sine function. So therefore, the function would be f of x equals negative 3 sine of 2x. Remember, a goes first, and b goes inside the parentheses with x. Number 4, so we have a positive cosine function with an amplitude of 3. So that means my a is positive 3. Now here the period is pi, and just like in number 3, the b value will be 2 again, right? It's the same thing. So let's skip the work. So therefore, my equation would be f of x equals 3 times, remember it's a cosine function, so write cos of 2x. All right, I'll go to the next two problems in just a moment. All right, so problems like these will correspond to number 5 on the lab. All right, so if you're comfortable doing these, the lab has 2 more just like it. All right, but now let's go to the next 2 and finish up these problems here. So in number 5, remember we said it was a negative cosine function with an amplitude of 2. So that means A is negative 2. The period was 4. I think we just did that in another problem, but that's all right. So remember the period is 2 pi. I'm sorry, the b value is 2 pi divided by period. So 2 pi over 4. Pi does not cancel out because there's no pi in the denominator, but 2 and 4 will reduce a little bit. So we get pi over 2. So therefore, the function is f of x equals a, negative 2. It's a cosine function of pi over 2 times x. All right, so remember it's the a value times the trig function of bx. So b was pi over 2 times x. All right, number 6. Okay, so again, let's look at the function. It's a negative cosine, and the amplitude was 1. So therefore, the a value is negative 1. The period is 3/2. So therefore, the b value is 2 pi divided by 3/2. You have a little simplifying to do. So this would be 2 pi over 1 times the reciprocal 2/3 is 4 pi over 3. And then the midline, the one thing we want to keep in mind there is like what the midline does, it shifts the function, let's just call it f of x, it shifts f of x up 1 from the x-axis. So we also have to make sure we include that in our equation. So the midline, remember this problem here, it wasn't the x-axis in this problem. It goes through 1, which means the entire graph is shifted up 1. So therefore, my function f of x will be, so remember a is negative 1 times, it's a cosine function of bx, so 4 pi over 3x plus 1. So the midline is what that 1 is there. So this is reflected right there. And therefore, my final equation is f of x equals negative cosine of 4 pi x over 3 plus 1. So notice that amplitude of negative 1, we can get rid of the 1, but we still need the negative there for an amplitude of 1, but it's a negative cosine function. Now let's suppose that this function was actually shifted down a couple of units. You would have to subtract the actual midline. All right. So if your midline was at negative 2, you would have to subtract 2. All right. So to summarize, All right, we would have f of x equals a times cosine or sine of bx plus d. So a would be the amplitude, or the absolute value of it. The period is 2 pi over b. And then the d value is actually the value of the midline. Now, when the midline is the x-axis, it actually goes away. It's 0 if x-axis. So notice we didn't have to worry about that in all the problems that we just did because the x-axis was the midline. So that d value would be a 0 and there would be nothing there in its place. Okay. One other thing I want to add to this summary now, and we're not actually going to worry about it, is what's called phase shift. I really don't focus so much on this in pre-calculus because in the years that I've either TA'd for calculus or actually taught calculus, this doesn't really come up in calculus. So, but for those who know about it, you might be wondering why I haven't covered it. And that's because I don't think you really need this for calculus so much. So phase shift is actually just a horizontal shift of the graph. So that essentially means this. So if I take like my sine function, for instance, which I'm going to draw very loosely, all right, this is regular sine. A phase shift would just take those points and move them over the same distance. So notice those two black points. If I move them both over to the right a little bit, the whole graph will shift to the right. So this would be sine shifted right. That's what we call a phase shift. Okay? Because it moves to the right. And the way that's determined, so like for example, we have f of x equals a times sine or cosine of bx. Here's your c, in case you're wondering where that was before. The phase shift is determined by negative c divided by b. So if you divide that, that will tell you how far you will shift. So this will be a shift to the right. So a right shift if positive. And it will be a left shift if it ends up being a negative value. Okay, that's it. I'm not going to do anything else with that. You really don't need to know that for calculus. But in case for those that knew about this, you were wondering, am I going to teach this or not? And I'm not. So this is all you're going to get for phase shift. Okay. All right, now I'm going to go back to some of the earlier pages in this plots for the week. So under Tuesday, number 3. And this is actually going to correspond to the last question on the lab. So after this page, I'm going to stop here for tonight. So number 3, I will do. So I will do number 3 with you. And what we're going to be doing is we're going to be graphing the cosecant function. Sorry. There we go. Okay. So we're going to be plotting together the cosecant function. And remember, the cosecant function is the reciprocal of sine. So it's really helpful to have the graph of sine available, because if you draw cosecant and sine together, you can actually see how they kind of piece together as reciprocals. And we're going to be using the notion of asymptotes. So asymptotes will be used here. So remember asymptotes from a couple of weeks ago, we'll be needing those. All right, and then number 4, this is lab question 6. So you'll be responsible for doing this on your lab. Okay. So let's go back up here and let's look at exactly what we got. So letter A, the graph of sine is given below. There it is, isn't it pretty? Okay. We're going to use this graph and our calculators to help us sketch cosecant. So the first thing we're going to do is highlight all the points where the sine is equal to 0. So first, let's go to the graph and highlight those. Where is the sine equal to 0? Well, everywhere it crosses the x-axis. So all these little red dots, that's where sine equals 0. So highlight those. All right, next sentence there. Now remember, when something equals 0, the reciprocal of this value is 1 over 0, or undefined. Okay, because remember, the cosecant is the reciprocal of all the sine values. So we need to take the reciprocal of 0, which is undefined. So remember, to represent an undefined value on a graph, you draw a vertical dotted line through the points where the sine is equal to 0. These dotted lines, remember, are called asymptotes. And that's where the function is undefined. Okay, so now what we're going to do, because remember, we're going to be drawing the reciprocal on this same graph. So what I need to do next is actually draw asymptotes through those dots. All right, because the cosecant is not 0 at those points. The cosecant is undefined at those points. So I need to get asymptotes at all those points. All right, don't be lazy and only copy half the graph. All right, do the whole thing. All right, so we just completed part A and B. So A and B are finished. C, find the points where sine is 1 and -1. So here I'm going to use blue to highlight 1s and -1s. Okay, so I'll use blue dots. Okay. And then also, the reciprocal of 1 is 1. The reciprocal of -1 is -1. So what these points represent are intersections of sine and cosecant, right? Because if sine is 1 and the reciprocal is 1, they're equal values. And if you remember from algebra, all right, 2 graphs intersect when they have equal values. All right, so 2 graphs intersect when they have equal values. All right, so like 1 and 1 are equal, -1 and -1 are equal. So now going to the graph here, sine is 1. All right, remember at the peaks and the minimums? So that should be labeled. So that would be this point, this point, this point, this point. There's a ton of them. Here, 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 and there. Okay, so what I have there on my graph, I have asymptotes for the cosecant function, and I have a couple of points that the cosecant function will pass through. So now I got to figure out, well, what does the cosecant look like? What are the curves? Okay, so now part D, I just did C. Part D, use the lines and the points on the graph here, as well as your calculator, to sketch the cosecant. Why do we need the calculator? We got to see what the curves look like. So let's do this. So first, I'm going to draw sine of x. Delete these 1s. And then I'm going to draw cosecant, which is 1 over sine. So to get the cosecant in here, I do 1 divided by sine of x. I'm going to change my window to look like the one that's on the page there. So if you hit window, we would be going from negative, let's say 4 pi, if we use the full left side of the graph. So we go from negative 4 pi to positive 4 pi. And then the x scale, it looks like it's steps of pi. Well, that was already there. And if I graph them together, there's the sine function, and there's the cosecant function in red. And notice that there's going to be asymptotes on each of these dots that you see here on the grid. So all those asymptotes that we drew are going to meet the red curves. Okay? So isn't that interesting that the sine is in the middle here, and the cosecant goes out the opposite way? All right? So let me, come on. There we go. So now how would I add this to my graph? It would be simply that. So I'm going to use blue here. So it would look like this. Kind of like parabolas fixed at those points that we drew in blue. But stay within the boundaries of the asymptotes. Don't cross the asymptotes. All right, and that keeps going forever and ever and ever. So what you see in blue there, that's the cosecant function. I don't think you really need arrows, but okay. Voila. There's the graph of the cosecant function. So now in number 4, all right, for lab question number 6, please use the full graph. Please use the values that are there, okay? And then just do the same steps above. You don't have to write out these sentences, okay? But use those sentences as a guide as to how to find the asymptotes and then those intersection points, all right? So like this part and this part is really important to kind of figure out how these two functions go together. Okay, so that will be from the lab. Okay, so I'll leave that up to you to do. And definitely use your calculator as a guide as well, so you can see where the curves sit on the graph. All right, and the last thing I'm going to show you here before I end class, next page, we don't have to write anything on here, but I just want to show you what the graph of tangent looks like. So the tangent is very similar as well. It has asymptotes. Because remember, the tangent, what just happened? There we go. Tangent, remember, is sine of x divided by cosine of x. So, and since it's a denominator, the denominator cosine can't be 0 anywhere. So, and the cosine is 0 at each of these asymptotes. So that's why there's asymptotes there. That's where the cosine is equal to 0. Okay? And the cosine is equal to 0 when x is, like, for example, pi over 2. So like this first asymptote right here, this is pi over 2. Right? Because this one here is 1 pi. Halfway is pi over 2. So 1/2 of pi. And then this one here would be 3 pi over 2. The next one would be 5 pi over 2. Okay? Etc. And of course, in the negative direction, it's the same thing. So we can generalize this a little more by saying it's plus or minus k times pi over 2, where k is odd. Because notice the numerators have odd numbers, 1 pi, 3 pi, 5 pi, okay? So the asymptotes occur at odd values of pi over 2. Okay, and notice that's also written down here. X is not equal to odd multiples of pi over 2. That's what I just wrote down there. Okay. And then the cotangent looks very similar. It also has asymptotes. But remember, cotangent is cosine over sine. So therefore, your denominator sine can't be 0. And that happens when x, all right, when x is a multiple of pi whole numbers, all right? So like here would be 1 pi, here would be 2 pi, and so on. So notice that those asymptotes are at whole number values of pi, like 1 pi, 2 pi, and so on. So when x is plus or minus k pi, where k is an integer or whole number, okay? So those are the graphs of tangent and cotangent. Now, let's take a look at these one more time and ask a couple of things. What's the amplitude of tangent? Remember, amplitude is height. What's the height of each of these curves? It's infinity. So we would say that there is no amplitude in these graphs because the heights are infinity. So therefore, you can't have amplitude. And finally, what's the period? What's the period of each of these curves? So let me switch to red. So the period would be the length of each of these little intervals that you see here. So what is the length of each of those intervals? So we can see that the right side there is pi over 2. The left side is negative pi over 2. So what's the distance from negative pi over 2 to pi over 2? All right, so therefore the period would be pi over 2 minus negative pi over 2. So we're going to be adding those. So it's pi over 2 plus pi over 2 is 2 pi over 2 is pi. So therefore, tangent has period of pi. So does cotangent. All right, so the period of this is also pi for the same exact reason. And this also has no amplitude. All right, so to summarize, let me go back to my notes. All right, so the periods of the trig functions, so remember, period, remember, is that horizontal length of one cycle or one frequency of the function itself. So remember, that just means that there's a certain shape or picture that goes with the function, and that shape just keeps repeating itself over and over and over, which is why they have these wavy looking lengths. It just keeps going up and down and up and down and up and down. It's repeating itself. All right, so let's call it, let's do a table. Function and period. And this will be useful tomorrow in our lecture. So sine, cosine, cosecant, and secant all have period 2 pi. And you can see that in their graphs. And we just saw for tangent and cotangent, they have periods of pi. So they are different periods for tangent and cotangent. All right, and that is the official end of class for tonight, folks. So finish copying down the table there. All right, and then you can stick around if you want and continue working on the lab and ask me questions. I will be happy to stick around. But if you don't need to ask any questions, you're free to go. So have a great night, and I will see you all tomorrow at 6 o'clock. I hope I gave you enough time to copy that.